Hi, everyone. Thank you for joining today. My name is Alex Sweetser. I am the Director of Customer Success here at Sedai. I'm also joined by Hari. Hari, if you want to introduce yourself.
Hello, good afternoon, everyone. I'm Hari Chandrasekhar, and I'm leading the engineering here at Sedai. And I'm also part of the team who's focusing more on the Kubernetes side of solutions for our product. Back to you, Lex.
Thanks, Hari. So I want to thank everyone for joining us today. We're going to be going through a workshop on autonomously reducing Kubernetes costs by 50%. And during this session, we want to cover some of the main challenges that Kubernetes users are seeing in the marketplace today in terms of managing for performance, managing for availability, managing for cost, and some of those other common challenges that we see. We also want to share what the Kubernetes best practices for optimization are. What levers should you be looking at? What levers should you be adjusting? What levers coincide with each other to get different outputs from performance and cost, or reducing cost without impacting performance? And then we want to cover how autonomous optimization is different. What is Sedai and other AI tools doing in the marketplace? And what does autonomous mean comparative to optimization? We'll then dive into some optimization scenarios of different things that we see in some of our own customer accounts, and give you a quick demo of how easy it is to set up Sedai and get running on autonomous Kubernetes cost savings and some of the results we've seen across our customer base. We'll open up for question and answer and next steps for everyone after that. If you do have any questions during the presentation, feel free to put it into chat and I will grab that, and Hari or myself will answer those in real time for you. So one of the challenges that we do see with our customers in running Kubernetes, either in a small environment or even at scale, is that as revenue increases, the cost of Kubernetes is commensurate with it and linear. So here you see an example of a SaaS cybersecurity company result that we saw in our environment, where on the left-hand side, you have the unoptimized numbers, and on the right-hand side, you have the optimized number. So we take the same revenue of 100 million in revenue and the cloud cost as a percentage of revenue. The unoptimized has an 8.6% margin on cloud cost as of revenue. But when you optimize for a decrease in that cost, most of the time these environments are over-provisioned. So that optimization drives down the cost with zero impact to performance, and your profit numbers begin to change. So a total impact of optimization on company profit with Sedai in place, autonomously managing your Kubernetes clusters, can result in a 17% swing in your profitability margins. Now, the reason we see this swing, or the difficulty in managing Kubernetes, one of the most common challenges is the over-provisioning problem. And this scenario probably sounds very familiar to a lot of you. We have a developer who wants to push a new version, an application into production, and wants to make sure that that application is performant, that all of the customers are receiving a good experience, there's no latency or degradation. So what they end up doing is allocating more memory or computes or different node sizes to ensure that there is no availability or performance problem, without really analyzing the configuration on cost, right? So that's really where we see the dev and ops divide. Developers want the best application, operations want the best performance and cost metric scenarios. So a lot of the time, they use standard sizes for applications that have different needs. So most of the time, you may have a team that says our applications are all going to release at this configuration of memory and computes and this node size, without understanding the complexities of all of the different levers that go into the seasonality of that application during different times, the compute requirements at different times, etc. So by default, a lot of these application owners are pushing into production and over provisioning to reduce that performance and availability risk. Now, the opportunity here that we've seen across our customer base is contributions from optimizing at each level. So when we look at the workload, we look at the node, and we look at the purchasing options. And we do this on an application by application basis, since each application needs or might need a different configuration than another application. What we've seen across our customer base is a 25% decrease in workload costs, a 25% decrease in node costs, and a 15% decrease in purchasing. Now, Hari will dive into these examples a little bit further into the presentation, as well as show you some of our customer examples in our platform to give you a better understanding of how these different levers can be autonomously managed to achieve these results. Ari, over to you.
Okay, thank you, Alex. So, as Alex mentioned, there are optimization opportunities at different levels. So, Kubernetes actually clearly falls into this modern application category where users can focus really on building solutions, business solutions, without really worrying too much about infrastructure. But among modern applications, Kubernetes is also the one which gives you a lot of bells and whistles so that you can fine tune your application to meet the real performance and cost needs that fits your needs. So that is also one of the reasons why Kubernetes is also popular in the first place. So you have more bells and whistles. That means there is a lot of responsibility on the users of Kubernetes to make sure it is fine tuned to best fit their needs, and Kubernetes is utilized in the best possible way. So when you're looking at optimization in general, there are different levels of optimization. You could start at the code level. There could be level optimization, just to name a few. But there are so many inputs which are outside of your control. For example, traffic. The traffic to the application is usually outside of the control of the person who is actually doing the optimization. So in this session, we'll just focus on the high level attributes, which are the basic necessity or the basic controls which can be utilized to make sure your Kubernetes cluster is running at its optimal best. So as I mentioned, there are factors which are outside of your control. Traffic is a good example. Now, most of the modern applications and with all the CI/CDs which are available, people are releasing more and more. Your business solutions are thrown into the production much faster. That means you have faster releases happening. So that means each application behavior is changing between releases. Those are the things which are outside of the control of the person who is actually managing the Kubernetes cluster and trying to make sure it is running at its optimal best. So if you look at the constraints that you have, the general goal here is get the best performance while keeping your cost at the minimum. Those are the very high level goals. Of course, there could be more specific needs for each application and for each customer, but in general, that's the high level goal. So as Alex mentioned earlier, when it comes to Kubernetes, you have some knobs available to fine tune so that you meet those resource requirements for the application so that it can perform at the required level while also maintaining the cost at the lowest level. So when it comes to Kubernetes, the basic knobs that you got is scaling your applications. That's the most basic things that you can do. The scaling can be both vertically by changing your CPU and memory so that your application has enough resources to perform, and also depending on your workload and the type of application, you can scale horizontally so that you can handle more traffic. So you always want to get the best performance from an application. But when it is the case of a cluster, there is not one application. You have a bunch of applications. You're mostly dealing with heterogeneous applications in a cluster. So that means the whole cluster is shared between different applications. That is where the cost benefit is going to come into. So that also means that you can't throw in infinite resources to any particular application. There needs to be a balance. So there needs to be an upper limit so that it doesn't stop, one application doesn't stop other applications, but it also makes sure you're fine tuned so that you get the best benefit from each individual application. So of course, the optimization has to start at a resource level, but then you really want to actually control your infrastructure also to make sure you get the best benefit. So in the case of scaling, let's say your application needs to deal with a bunch of increased traffic at a certain point of time. So that means you want to scale your application. At the same time, if your cluster doesn't have enough infrastructure to manage, that means you won't be able to actually scale. The increased requirements on the resource won't be met. So that means you need to have a scaling at a cluster level. Increase or decrease infrastructure to meet your application needs, decrease when you don't need it. And of course, when it comes to the cluster providers, there are a bunch of cost saving options. So let's take AWS as an example. You can sign up for compute savings plan, so that if you know that you have certain compute requirements, you can sign up for longer commitments, 1 year, 2 year, 3 year, and get discounts on those savings as well. So if you put all those things into perspective, so to really run an application in an optimal way, you have a lot of variables to choose from. Some of the variables are outside of your control, but of course, you need to actually prepare your cluster to handle those variable or factors which are outside of your control. So let's take an example here, a cluster with around, like, let's say 100 microservices. It need not be microservices, it could be any type of application there. Every application is different. Every application handles traffic in a different way. Some applications work well if you throw in more CPU or more memory. Some applications are thread dependent, so throwing more resources like memory and CPU may not work. So to handle the different varying traffic, you probably might have to scale up vertically or horizontally. So you have to deal with HP and VPA. Now, when you are scaling, you need to understand some attribute which reflects the application behavior. One of the most commonly used ones are the resource usage, the saturation metrics, CPU, memory, and see, if there is an increase in CPU usage, that means your application might reach the threshold. So you want to actually scale up either vertically or increase the number of workloads so that you can distribute the traffic. But the right attribute that you have to choose is going to be totally different between different applications. For some applications, the CPU, the saturation metrics might be the best representation of what is going on. For some other applications, that may not be the case. There could be other factors. Maybe the traffic itself is the right metric to actually do a scaling. And then, as I mentioned, different traffic patterns. Most of the application, let's say if you take a typical example of an application which is user facing, you probably are dealing with different type of traffic patterns. The one in the morning may not be the one in the afternoon, and it could vary across the days of the week. So on an average, you're probably dealing with around like 3 different traffic patterns per application, and it could be more than that, or some of the applications might not have that many different varying traffic patterns as well. Now, as I mentioned, all the optimization that you're doing at the workload, if you really want to take advantage at a cost and even at the performance level, you probably have to actually fine tune your infrastructure, which is backing your Kubernetes clusters. So, good thing or bad thing, if you're using a provider like AWS, you have a plethora of infrastructure options to choose from. So, we are being very conservative here. If you look at the screen, we have listed 5 different node types to choose from. Actually, it is way more than that. But for the time being, if you assume that you have to always choose, we have somehow narrowed it down to 5 different node types. You still have to choose which one is the right one for your workload. And assuming that there are 4 releases per application, assuming that it's a weekly release, you are dealing with around 36 different combinations to fine tune your Kubernetes cluster to make sure that your Kubernetes cluster is in the best optimal way. You are dealing with around 36,000 different combinations. Any change in any of these variables could actually result in either a performance impact or you might be losing cost. And some of these variables are also dependent on each other. For example, the performance of an application could depend on your CPU, memory combination, and the type of VM which are used. And of course, variables like traffic also has an indirect impact. So all these things which will result in an impact of your performance and your cost. So if you're really trying to actually fine tune your application the best possible way, you're dealing with these many different combinations on a monthly basis. Okay, Alex, can we move on to the next one? Okay, so now that you've seen the complexity, like how complex it is to really run a Kubernetes cluster in the most optimal way, you can see how hard it is going to be to automate it. So, if you break down the task to optimize, the basic things that you want to deal with it is, first of all, you have to detect the optimization opportunities, or those thresholds or those triggers when you want to scale your application and your infrastructure. And then when you detect a situation which needs changing your application configurations, you also have to figure out what is the right configuration which should be applied to get the best benefit out of it. And then the third thing, which is very critical, is you have to validate. Okay, you figured out a situation, you recommended something, you have to also validate and see, okay, I'm projecting or I'm predicting something, is it really going to work? And then, of course, the last thing is executing all these changes. When it comes to automation, if you're trying to automate it for each individual resource, you can see how much of manual effort is going to be there. Even if you automate, you have to, the first two steps of detecting and recommending requires a lot of manual input, and the validation and execution is almost practically impossible to automate. And that is where an autonomous system like Sedai is going to help, where all these steps are going to be available out of the box for you. Alex, can you move on to the next slide? So to dig a little bit more deeper into those steps, um, comparing automation. If you're trying to automate your optimization, you you have to detect what type of metrics. Like you have to first understand your cluster, different type of applications, and what are the right metrics to first of all to detect that there is an optimization opportunity. It could be a scaling, it could be an immediate scaling, or it could be a long-term change that you could be applying. So in for both of these scenarios, you have to first figure out what is the right attribute that you need to observe for a given application, so that you know when to scale and when to scale up or when to scale down. As I mentioned, different applications are going to be totally different. So let's say take an example of an application where saturation, CPU or memory usage is the right metrics, which kind of reflects what is going on in the application. Even if you take two applications of a similar nature, let's say two different web applications, the CPU limit for one application where you start seeing problem, mainly when we are talking about the CPU thresholds, we are seeing a threshold beyond which the application will start working erratically. So you want to make sure you do something at that point. And CPU, even if CPU reflects the right behavior for an application, it doesn't mean that two different applications have the same threshold. Each one are going to be totally different. And the thresholds, right? When it comes to Kubernetes, we are actually trying to maximize your cost, maximize the resource usage. You ideally want to be running at like 100% resource utilization, so that you get the best benefit. But ideally, you don't want to be hitting that limit. You want to be at a safer limit, so much smaller than that. So you know when to actually scale up, when to scale down. You have that opportunity to do so. But again, as I mentioned, every application is going to be different, and between even with one application, between releases, things are going to be different. And of course, when it comes to infrastructure, all these optimization that you're doing at an application level, you somehow want to maximize by choosing the right infrastructure. Some people choose not to deal with infrastructure at all. So, for example, if you're using AWS Fargate, you're letting the Kubernetes cluster manage the whole infrastructure for you. In such cases, of course, you're going to deal with whatever infrastructure is available for you. But if you want to fine tune and you have a very specific performance need, you may want to actually pick the right nodes, right VMs, which suits your workloads. And again, if you're trying to automate it, you're going to do some kind of a scripted remediation, whether it comes to optimization or whether it comes to availability. You're trying to do some kind of a scripted remediation. You see a problem, It's more like an IFTT kind of a thing. You see a problem, you do some certain things. But a lot of times, there is not one remediation for one situation that you're seeing. Say, for example, you're seeing an increase in the CPU. Does that always mean that you need to actually increase your workload, the number of replicas? It may or may not be. Sometimes it could be an availability issue, a bug in the system which just got triggered, and suddenly one of the replicas has a high increase in CPU. So even if you go with a scripted remediation, you're probably not going to get it right all the time. You have to constantly evolve it between releases to make sure your scripts are running at the best. And of course, the scripts, all the remediations, all the automation that you're going to not going to work all the time. So you always want to have some kind of a user intervention at a certain point. So you want the system to actually know its limitation and call for help if required. So if you're trying to do a scripted one, you have to actually configure everything. You probably want to write some kind of a script which talks to your notification provider, alerts you, and that also needs constant reevaluation to see if it is working at the finest and if it is notifying users when it is really required. With autonomous system, all these steps that we just mentioned are going to be available out of the box for you. And with Sedai, we know we integrate with different notification providers, so you can actually fine tune the type of notification that you're getting and in which channel. And in so if you look at an autonomous system, if you sum up all those things that we just mentioned, right, setting up thresholds and all, the high level goal for the user who is actually trying to optimize your Kubernetes cluster is setting a goal. With a system like Sedai, what we believe is the user should define what their goal is without really having to figure out these nitty-gritty details of individual application. Doing it one time for an application might be fun for some users, but doing it for all the applications on a continuous basis is never an easy task. It is also not a fun thing to do. So that is where Sedai comes in and solves those toil for the user. So Sedai will take up those the basic level things, the basic level toil, and actually let the user define a high level goal. So if you look at the screen that you're seeing here, it's an optimization configuration where the user can come in and say that, okay, I want to actually optimize for both cost and duration. So you're effectively asking Sedai to say, for your workloads, I want to optimize for cost. At the same time, I don't want to actually take an impact on the performance as well. But in some cases, you have a slightly different goal. There are some certain applications where you're not too much concerned about your performance. You can take a hit on the performance. It could be a batch processing system. It doesn't have a user-facing interface where goals could be slightly different. So Sarai actually lets you define your goal, the high-level goals, and you can also put constraints saying that, okay, if you're trying to improve performance on an application, do not go more than, let's say, 25% of your current resource usage cost. So that is how Sedai operates it. And here are a few examples on the optimization that Sedai does. These are some of these examples are from some of the customer environments. So of course, the names are changed, but here is a very obvious one. In this example, if you look at those two columns, before and after, the first rows are showing the memory and CPU configurations for the individual containers. As you can see here, Sera has gone and reduced the resource usage or resource request and limits for all the containers, effectively resulting in lesser resource usage and of course saving on cost. So in this example, we did it without really impacting the performance at all. So effectively, we were dealing with over provisioning. So this is the more trivial examples what you usually see. If you look at most of the cost optimization tools, they are looking at the current resource usage and coming up with the recommendation. This is the more obvious thing that even Sedai does. But let's take a look at one which is not so trivial. So here is an example of a web application where we had a latency requirement of under 10 milliseconds, and there was a cost budget. So if you look at the column on the left, before, that particular application ran with around 800 millicore CPU with an upper limit of 1.2 cores with a fixed memory of 1 GB with 10 replicas and a VM, with a node affinity, which made it run on M5X large. We met the resource requirement, we met the performance requirements, and it was also within the cost budget. But Sedai was able to actually fine tune this application where it actually increased the memory of an individual pod. It was able to reduce the CPU requirement and also reduce the number of replicas, use a slightly different VM, and with which it was able to get even better performance at a lower cost. So these are things, these are opportunities which are not so trivial. It requires a lot of deep insight into the application. And Sedai uses an ML model to actually come up with some of these projections on how we can optimize different applications. And also, we go through a reinforcement learning, um, which validates the recommendation that Sedai has. And also, we have a lot of safety checks with which we make sure the changes that we are making is in fact making the right change that we are expecting and back of it required. So in this example, we were able to actually get 48% savings by increasing the memory, which was actually not a very trivial one if you just look at the application. And it was already an application which was performing well, but we could make it better, both cost savings and performance savings. Okay, so we'll just quickly switch over to a small demo on how to set up an account in Sedai, so that we'll show you how to actually connect a Kubernetes a cluster so that Sedai can autonomously monitor and actually start recommending the changes that it sees as opportunities. Okay, so if you go to sedai.io, you can click on the start free here. I'm already logged into the system, so it actually brought me here. But if you're trying to sign up for Sedai, you will see a screen where you can actually create an account or sign in with Google. It requires validation of your email, unless you're using Google, of course. Um, so once you are in, you will see a screen like this where you can actually connect your Kubernetes cluster. We support AWS and other services too, but in this demo, we'll just focus on Kubernetes. So if you want to add like a Kubernetes cluster, you can click on here, and we support different cluster provider. Um, Sedai's main goal is actually to make sure things are easier for SREs or whoever is managing your cloud provider. So we want to be as non-intrusive as possible. So we try to actually connect your cluster using APIs, try to connect your monitoring providers using APIs, and collect metrics, make inference on your application, and then start recommending and of course autonomously executing on them. So in this example, I'm going to show you how to connect to your Kubernetes. Even for Kubernetes clusters, we have two ways of connecting. One, as I mentioned, as a non-intrusive one, where you do not have to actually install anything in your agent. Another option is actually to install an agent. So based on our experience, a lot of customers requested the agent-based approach. So that is the one that I'm going to show here. Okay, so I'm going to pick EKS. So you can give a name for the cluster here. So this is something so that you can reference back in Sedai. We would recommend giving the same cluster name that you're using in your EKS. And the second thing Sedai wants is monitoring provider. So Sedai is not an APM by itself. What it does is it connects to your monitoring provider. It collects the topology information, like for example, connecting to your Kubernetes control plane and understanding your deployment, your replica set, all the workloads that you're using, node level information, and then connecting to your monitoring provider, collecting the data, the metrics, and correlating with your application, and trying to infer application behavior from it. So usually we collect mainly the golden metrics. We try to collect the traffic, the saturation, error, latency. So effectively, we know the input coming in using the traffic information, how your application is performing using the latency metric, the error metrics, and of course the resource usage metrics. And on top of it, we can also use the application specific metric that is being emitted. The only constraint there is it needs to be somehow mapped to, for example, if it is Kubernetes, there needs to be a mapping back to your infrastructure. So for example, if your metrics have the appropriate label on which infrastructure it is coming from, Sedai will be able to utilize it. So in this case, I'm going to just choose Prometheus. So if you're choosing Prometheus, you can specify the, the URL on how to connect to Prometheus here, the type of authentication that your Prometheus supports, JWT, and if it is on-prem, most likely you won't have credentials. And in this flow, since I chose the agent-based one, uh, the agent is going to be sitting inside your Kubernetes cluster. Of course, this flow will require an agent installation inside Sedai. So that agent is the one which will be connecting to your Kubernetes control plane and your monitoring provider. So this URL, the Prometheus endpoint, doesn't need to be a public one. It is going to be within, the agent needs to be able to access your Prometheus endpoint. That is only requirement here. Okay, so I'm going to just leave it alone. Done, and you can confirm the setup. Right now, I'm not going to actually go through the complete setup. So once this step is done, you will have an environment provisioned within Sedai for your company. So for example, we have a demo environment here. So once it is provisioned, you will be able to, in this screen, in the app.sedai.io that you're seeing here, once you have added all your monitoring provider, the system will go through the provisioning step and log you into Sedai, and you'll be using the same login that you created when you come into Sedai. So this is the homepage of Sedai, where you can see, the top level is just giving you an information on the application that Sedai is seeing. Since we support different cloud providers, we have abstracted it out into applications. So in Kubernetes world, this is going to be the workloads. And on the homepage is actually going to show you the recommendations that Sedai has. So in general, Sedai does both availability and optimization recommendations. Availability is more dealing with things that Sedai is seeing on an ongoing basis. So for example, as I mentioned, when you're dealing with workloads, you want to make sure your one workload doesn't starve other workload. And there could be an incorrect configuration, for example, where the user has allocated less memory than it really needs. In such cases, Kubernetes will throw, your application will run into out of memory and Kubernetes will restart it. So Sedai will be observing those kind of patterns and recommend you to actually change that one on a dynamic basis so that you don't run into all these issues. So initially, it'll start seeing applications behaving. For example, let's take an example here. CPU limit is not set. So that means your application is probably going to hurt other applications. CPU usage approaching limits. So in such cases, that means your application is probably going to run into throttles pretty soon. So based on application behavior, so Sedai looks at the past behavior of the application and tries to build a model out of it. So if it sees that the application is constantly requiring more CPU than what it is already set, that means your configuration is probably incorrect. So that incorrect configuration could result in availability issues. Either it could be CPU throttling or it could be out of memory, both of them, which is going to result in availability issues for the user. Okay, so the other thing from a Kubernetes perspective, so once Sedai has a couple of weeks worth of data, it can start showing optimization opportunities that it is seeing. So as we mentioned, in Kubernetes, we try to do optimizing multiple levels. We start with workload. We try to optimize all the workloads so that it is performing at its best with the lowest possible cost, and then compound that optimization that we have done take it into the infrastructure level, node optimization. So if you see here on the top, what you're seeing is if you do all the workload optimization, node optimization, and the purchasing options suggestions that Sedai has, we could result in almost a 66 percentage monthly savings. Effectively, what we are seeing here is we could reduce your monthly cost from 11,000 to almost um, $3,700. And the way we achieve is using cluster, node, and purchasing options. So as you can see here, we are going through each individual workloads and figuring out optimization opportunities. So this is based on the application behavior that it observes. So it looks at a big range of your application behavior, and it is doing it on a constant basis. So I understand the releases happening, and it actually re-evaluates its model when the new release comes in. It actually accommodates that application behavior change that it's noticing, and based on that, it continuously keeps on recommending what would be the ideal right sizing for your workloads. So as you can see at an individual resource level, it finds opportunities on how to optimize. Second thing is it takes all those workload optimization. Now it brings it into node level. The way Sedai recommends node level recommendation is using the different workloads. So it figures out what type of infrastructure needs each application has. So your cluster could be running heterogeneous workloads. Some applications might be memory intensive, some might be CPU intensive, some might be really dependent on the network input output. So using those information, Sedai actually tries to figure out what would be the ideal VM which suits your application. So it has algorithm, it has ML models which actually projects what type of VMs would benefit best. And in this case, the one that we are looking at is an AWS based cluster. So it actually figures out what would be the right VMs which suits your workload. Of course, if you're using Fargate, so I won't be able to actually recommend anything because you're going to choose with whatever Fargate is going to offer you. And depending on your cluster provider, we take those two recommendations and also see how we can actually benefit from purchasing options. So it's going to give you a recommendation on how much cost savings you will get if you go with a 1 year compute savings plan or a 3 year. So all these things it's calculating based on the projections that it's making. Now let me show you an example of the goals that we talked about. So if you see here, under settings, you can actually click on the cluster that you have added and you can define the high level goals, what said I should be doing. So in this case, we are talking about cost and latency. So how do you want Sedai to optimize your configuration? So in this case, we are saying, okay, we want to get the best of both worlds. So in that case, Sedai try to keep your latency at the baseline that it is seeing and tries to improve on the cost. It won't worsen your latency. But of course, as I mentioned, you could have different requirements on different workloads. There could be cases where you really want to save cost. The cost is reflective of how much resource usage you have. So you could say that, hey, I want to reduce the resource usage, but you can also put a constraint to Sedai and say that do not increase the latency, the baseline latency that Sedai is seeing more than 20%. So in such cases, you are actually letting a performance hit on certain applications for a cost benefit. And of course, similar to that, you can also specify that, okay, I want to actually improve the performance of an application, but you can actually put constraints on how much increase in CPU and memory you can accommodate. Okay, so this setting you can actually perform at an account level, at a cluster level, or you can actually do it on an individual workload level. So you can have an account level default, which could be best of both worlds, and you could pick and choose individual resource and say that, okay, for this application or for this workload, I really don't care about cost. I want to get the best performance because it's a user facing application, or it could be the other way. It is not a user facing application. I just want to save cost. It really doesn't matter how much time it takes to execute. So you could have a totally different setting. So let me show you a few examples on how those recommendations. So once Sedai sees that goal and operates on workloads, here are some of the results. So here is an application. This is from our demo applications. So we set the goal to decrease duration. So what we did was we actually looked at the application, and then we were able to make changes so that the performance is improved. And the way we do that, here in this case, this application responded very well to increase in CPU. So without any other change, no change in memory, no replica set, just by increasing the CPU of the individual replicas, we were able to achieve almost like 42% reduction in the duration. Okay, so this is with a very specific goal of duration. Of course, this means there is actually a slight increase in the resource usage and a slightly increase in the cost. Okay, let's take another example. So here the goal was decrease cost and duration. So even if you set the goal, it doesn't mean that Sarai will be able to actually achieve it in all resources. It will attempt, it'll look at the application behavior, it will see what is possible and tries to actually apply the configuration where it sees that opportunity. So the examples that I'm showing are the ones where Sarai was able to operate. It found opportunities based on the goals and it has executed on it. So if you see here, again, here we were able to achieve a better performance by reducing the resource usage as well. So if you see, there is a 13% reduction in the latency. Again, there was an overall reduction in the CPU and memory. The way it did it is, uh, it's very similar to the example that we saw earlier in the presentation. So in this example, Sedai increased the CPU on individual replicas, no change in memory, but it reduced the number of replicas. So just with two replicas, it was able to achieve the same performance or even a better performance for the same traffic. And again, a very similar example. Here, we wanted to actually reduce cost on this application. The way Sedai achieved it is by having a hit on the performance. So if you look at it, the way Sedai did it is it reduced the memory on each individual pod, no other changes, and just using that one, it was able to gain performance, but of course at the cost of improved latency. And even the latency increase, as I showed earlier, you can put constraints on Sedai to say that, okay, do not increase your latency. So the baseline is what Sedai sees initially when we look at your cluster. And of course, you can put constraints and say that do not increase more than 20%. So it'll look at all the different opportunities. Some applications work well with the CPU changes, some doesn't. Some reflects well with the memory. So it figures out what is the right one or what is the right opportunity uh, um, to make the changes so that you can achieve the goal. Okay, and as I mentioned earlier, Sedai also looks at changes happening in the application. It is constantly looking at all the workloads, and it is seeing all the changes happening in the application. So this is something that Sedai internally uses for its algorithms to understand the application behavior and all. But we have also brought it out for the users so that whatever we are seeing, we are actually coming in with a scorecards. Every time we see a new release on workloads, we are actually doing an evaluation. So effectively, what we do is we do it in two phases. One is a preliminary one. So the goal here is, as soon as we see a new release, we actually try to see how that application is behaving. We take the smallest drop of metrics that we get, traffic and performance, and say, okay, in the past, this application used to perform in a certain way. We might have already built a model based on that one. So we see, okay, for the after the release with the current traffic, what are we expecting the application to do? Using that information, we actually project what is supposed to do and what it is actually doing. And if we see a difference, we actually put it out and show it to the user and saying, hey, we are seeing this application release. It is performing, the latency, the duration is actually much worse than it used to be, or it could be better too. Either way, we bring it out to the user. If the application is behaving almost similar to what it used to be, we give a perfect score. So the goal here is to let the user have a glimpse of how the application is performing after the release. So let's take an example. So these are all 10 out of 10. So that means the release is actually not doing anything different. So let's take an example here where we are seeing moderate changes. So if you see here, considerably shorter latency. So the main thing here we wanted to highlight is it is actually performing better. If you look at it, what we are seeing is the application performance has improved from what it used to be. But we are still bringing it out to the user because it may be an intended result or it may be unintentional. For example, there could be a bug with which a portion of the code is not getting executed. That might be the reason why the performance has improved. So the metrics are showing a good result. You're seeing a better latency, but it may not always be a good thing. Sedai doesn't autonomously do anything with it. We autonomously detect releases, we generate the reports, and notify user if we see a considerable deviation. But the main purpose of release intelligence is to actually bring out insights into the releases happening, and we do it as soon as we detect a release. So here you see this moderate deviations. The reason why Sedai brought it up is because the latency is considerably shorter than what it used to be. And of course, you can see here slightly longer latency duration. So there was a release after which the latency, the performance has gone worse actually. It's slightly bad. So this might be something that the developers can be notified so that they can review what is going on with the application release and make corrective actions. Okay. Um, So I think I gave a very high level overview of how Sedai operates, mainly optimization and availability based recommendations and release intelligence. Um, of course, we are open to questions. And back to you, Alex.
That was great, Hari. Thank you. So we'll open it up to the audience. We have about 10 minutes left. If there's any pressing questions or use cases that you see in your own environments that you'd like us to talk through. So we have a question. Does this work for any Kubernetes distribution?
Okay, I'll take that. Yes. So we have two approaches how we connect to the Kubernetes clusters. One is agentless and one is agent based. The agent based can work on any Kubernetes clusters. Once you add an account, you will get instructions on how to install an agent. If you go install it on an agent, that agent is going to talk to your Kubernetes control plane from within your cluster, and it can connect regardless of who the cluster provider is. Where the cluster provider comes into picture is when Sedai has to do node level recommendations. So right now we support most of the major cluster providers, AWS, Azure, and we can come up with the recommendations.
Thank you, Hari. We have another question. How long does it take for results to come through in terms of cost reductions?
So for cost reductions, what we generally recommend is at least that I should see at least 2 weeks worth of data. That's approximately when so I can start recommending a good number. So the reason for that 2 weeks is actually for Sedai to have enough data to build the models, and so that it sees all the different patterns, traffic patterns, application behavior, happening in your cluster. So in and around 2 weeks, there should be opportunities that Sedai is seeing, and cost level recommendations should start showing up.
Great. Thank you, Hari. How does Sedai work with tools like Kita and Carpenter?
So Kida, Sedai's main goal is actually to configure your system in the best possible way. So if you take a example of Carpenter, Carpenter is the cluster auto scaling solutions from AWS. Right now, it works mainly in AWS clusters, but I believe it is going to be expanded to other providers as well. Um, so, so the main value add that Sedai is going to bring in is Sedai has insights into your application behavior. So Carpenter actually does a very good job of not the user not having to configure your node groups and all. It tries to pick up the right VMs which suits the needs at any point of time, and there is also a rebalancing. What Sedai brings in is Sedai has better insights into your application. So it understands what type of VMs best suits your application on a on a larger perspective. So Sedai can configure Carpenter to make sure that it knows the smaller set of VMs which works best for these workloads. So it kind of adds on to what Carpenter offers. So Kida is of course it lets you pick event based scaling and all. So Sarai's value add here is again the same intelligence, the application specific. Even if, like for example, two web applications, right, these two web applications could be different. So Kira lets you actually use the right metrics or right event to scale. Sarai will help you with configuring it in the right possible way.
Got it. And what happens to the new configurations that I has made when I make a new release?
So this, I believe, this question is more related to the CI/CD. So most of the clusters, customers uses some sort of source of truth, like some kind of a GitOps, to make sure um, the GitHub repository. There is an IAC which is actually somehow translated into your cluster. So we have multiple options. The best possible solution that we have seen so far is let Sedai manage the resource configurations so that the customers can completely remove the resource configuration from their GitOps workflow. Um, we work, from our testing, what we have seen is most of the tools work very well with this approach. So, for example, so what Sedai does is very similar to how an auto scaling an application configured with an HPA would work. So the replica set is dynamic in the runtime. It doesn't need to be in the GitOps. So Sedai can actually handle it, and the tools usually sync up. But we also offer alternatives too. The first thing is we call it Sedai Sync. So what we do is we let these tools overwrite the configuration that Sedai has made. But as soon as Sedai detects a release, it knows what is the right configuration for that application. It tries to put it back. This works very well if the GitOps tool is not actively syncing, every second or every minute. If it is only pushing the changes during a release, this approach would work. The other alternatives is we have webhook notifications. So every time Sedai makes a change, it can push the change to a webhook notification. And we also have a GitOps integration where Sedai can continuously push the configuration that it is making to GitHub or GitLabs integrations, which is provided to Sedai. So there are plenty of options to work around the CI/CD. But as I mentioned, the one that we have seen work very well is where the GitOps ignores the GitOps workflow, does not specify the attributes that Sedai manages, and let Sedai do it.
Got it. Thank you, Hari. How does this compare to something like cube cost?
Right, yeah. So as I mentioned earlier, most of the optimization tools, they're looking at resource usage of an application or in your cluster and recommending changes. The main difference that Sedai brings in is Sedai actually first focuses on the application. We try to start from the application, understand what each application needs, what the behavior is, and then first optimize there, and then use that to compound it to the other levels like node. So if you look at cube cost, it's mostly a point of time. You can get recommendation within a few minutes. That's because things are, only the resource usage is looked at, mainly the resource usage is looked at, and you get instant recommendation. What Sedai does it is Sedai does it on a continuous basis. We know that the application changes over time, the traffic changes over time, releases happens. So we have to continuously optimize. So that is the main difference or main value add that Sedai brings in.
Thank you, Hari. How are you ensuring that everything you execute is safe and does not bring down the cluster?
Yeah. So when it comes to autonomous execution, even in Sedai, the first thing that we have is safety. So we have a bunch of safety checks for every execution that we make. It could start from very trivial things like, hey, I mean, does it make sense? Like, is it like 100% increase? Is that going to work? Does the cluster have the capacity to more sophisticated ML based safety checks? And we do it on every step that we are executing, like where all the changes that we are making. And we also have something called efficacy checks. We just don't make changes and leave it alone. After, let's say, we make a recommendation, we autonomously execute. We have say efficacy checks for all the operations that we are doing. We look at the impact of the change that we are making, because whenever we are making a change, we have a goal, we have a reason why we are changing. So we always look back and see, did we meet that goal, did we improve things? And we should not be making it worse. If things are worse, we try to revert it. We, worst case, we'll call for help. But first thing, safety is always the primary thing that we check for before um, you know doing any operations autonomously.
Got it. And do you work with any other technologies besides Kubernetes?
Yeah, so Sedai's primary algorithm will work with any cloud provider. We support AWS, we support serverless functions, and we can even support applications, balancer based ECS. So we have our solution works with different cloud providers.
Okay. And as a next step for everyone joining today, we are running a promotion. So for anybody that goes ahead and signs up for Sedai and you run 100% autonomous with 100 plus pods in your environment for 2 weeks, we'll send you a $200 gift card. And of course, bring down the cost of your Kubernetes, which is also a win. We do have 2 minutes left, so if there's any last minute questions, we're happy to answer those as well.
Okay, I see a question. How is it different or okay, sorry, I'm seeing a different one. Huh?
How is it different or better than HPA VPA?
Okay, so HPA VPA, if you look at it, it lets you configure a metric and a threshold. So you have to first pick up the right metric for each application, and then mostly if you look at Kubernetes HPA, it works very well with the resource usage metric. But of course, custom metrics are also supported. But you have to first figure out the right configuration and the right metric. Like even within the resource metrics, which is kind of available out of the box in a way, even for that one, you have to figure out what is the right metric and the right configuration to use. And at this point, I believe there is a slight limitation on using it together. Of course, that limitation might go away in the future. But even if you're doing it, it's the responsibility of the user to figure out which one to use, what threshold to use, and when you're using it together, make sure that it is configured the right way. With Sedai, you're effectively threshold free. You don't have to figure out what is the right configuration. Sedai tries to pick up the right metric, which reflects your application performance the best. So, and it does it in a constant basis, even between releases. So that there could be application V1 where it was completely dependent on CPU, and after like 3 or 4 releases, the application behavior completely changed, and suddenly it is very sensitive to the memory. So in such cases, your threshold or the metric itself has changed, let alone the threshold. So if you're using HPA and VPA, it becomes a user's responsibility to configure it in the right way. With Sedai, you can completely forget about using, or figuring out the right metric and the right threshold on a per application basis. This will be completely taken care by Sedai.
Perfect. Thank you, Hari. So we want to thank everyone for joining. If you have any additional questions, you could reach out to contact@sedai.io. You can go to our website, sign up for a free account, or a free trial to test this out in your environment. Of course, you can start with recommend only. We won't make any changes in your environment until you give us the go-ahead. So we look forward to hearing from you. Thanks, everyone.
Thank you, everyone.